We're going to look at a couple of questions when we combine all of our transformations. Now, we could include rotations, reflections, or translations here, or possibly dilations, but less likely that's going to be an issue here. So we're going to look at drawing shapes that are rotated, reflected, and translated. Suppose the rectangle that we see below is reflected over the y-axis. Which transformation will create the same image? Is it rotation 90 degrees clockwise, translation 10 units left, translation 10 units right, or rotation 90 degrees counterclockwise? Now, if we take each one at a time. A rotation 90 degrees clockwise would look something like this, not the first one. 90 degrees clockwise. So we're going to end up with our shape somewhere down here. That is definitely not going to be the same as reflecting over the y-axis. Reflecting over the y-axis means my object, my image, is going to end up over here. So reflecting 90 degrees clockwise is not going to do it. Right? How about translation 10 units to the left? So moving to the left means I'm going to be going this way. Well, that appears that that's going to do it, isn't it? If I move 10 units to the left, it's not exactly the same as a reflection, but the nice thing is we have a rectangle. And in a rectangle, your opposite sides are equal. So even though in a reflection, this side right here ends up over here, we know that this side right here is equal to this side. So that means that this side here and this side here are equal. So when I translate, I'm going to end up with my object here. But because the rectangle is identical on opposite sides, my translation 10 units left does appear to give me the exact same picture as a reflection through the y-axis. So the answer is going to be B. But I'm just going to look at the other options here. So a translation 10 units to the right, so that means my object is moving way over here. My line of reflection is right here. So that's definitely not going to work. A rotation 90 degrees counterclockwise, that's going to be in this direction, but my object is going to end up vertical like this. So that means that this one is no good. This one, of course, is no good, and this one, of course, is no good. So the only option that does actually work here would be a translation of 10 units to the left. Okay, we want to now describe the transformation or transformations that create A from C. So I start with C, right here, and I want to create A. So notice, how far away is C from my y-axis? Right here I've got 2 units to the right of my y-axis, and I have 2 units to the left of my y-axis. I get the exact same point on A. So it appears to me that this is a reflection in the y-axis. Okay, how do I get from C to B? Or C from B, apologies. So I'm at B up here. Get my pen. I'm at B up here. And I'm going to go to C. They have the exact same orientation. They're the exact same size. So what I appear to have done is I've translated. But how many units have I translated? That'll be 1, 2, 3, 4 down. So to get C from B, I translate 4 units down. Okay, let's see what we can do. How do we got D from C? Well, it appears to me that what I've done with C is that I've taken this point right here, and that would be the center of a rotation. And C gets rotated 180 degrees until we see D. There's another way we can describe that, but that's the way I'm looking at it right now. So I would say a 180 degree rotation about the point 4, 2. That's my center of rotation right here, 4, 2. Another way we could describe this would probably be a reflection. You can look at it this way, a reflection through that line there, and that would give me this image right here, and then another reflection through this line, which will give me what I see for D. So either one of those is correct. So there's more than one way to possibly do a translation. So I'm going to write that down below as well. For C, we could have also done a reflection through the line, the first line, which would be y equals 2, then another reflection. So two transformations, another reflection through the line x equals 4. So there's 2 ways that I can see for sure that I can do D. Now there's possibly other ways you can maybe come up with. Okay, so lastly I want to find out how I get B from A. So notice that A, the sharpest point in the triangle in A is pointing to the right, whereas that same point is pointing to the left in B. So, and also notice that A is 1, 2 units to the left of the y-axis, and B is 1, 2 units to the right. So I see a reflection through Y. So I'll say a reflection in the y-axis. But then we also have to go up. That'll give me, this point right here would end up basically looking just like C. And to get from C to B, I'd have to go up 1, 2, 3, 4 units. So then, translation, 4 units up. And that'll get me B from my starting shape of A. So we have 2 ways, I should write the word then here. We have 2 ways of finding C. We have one way, there's probably multiple ways you can find the other ones, but I found one way to find A, one way to find B, and one way to find D. So you may find other options, but these are definitely good options here. And again, we're seeing that we can do all kinds of different types of transformations. Reflections, translations, and rotations are all accounted for here. So to summarize, we can combine any number of transformations to create a new image. And it is possible that there is more than one transformation that will give the same image, like we saw in example C in question 2.